In this tutorial, we are going to use Deeptrack 2.0 in order to characterize the refractive index and the size of microscopic particles. Hello, I am Aykut and I will be your guide for this tutorial.
We start by running this cell, which makes sure that all of the packages related to Deeptrack are loaded. Then we load the objects that are needed to run this example. Once this is complete, I will move on to defining the dataset. For this, we start by defining a sphere function. So here we are creating a position of the particle along x and y randomly, and then position of the particle along z-axis randomly, and then we are going to assign a random radius to our particle and a random refractive index. The radius will be between 100 nanometers and 400 nanometers, and the refractive index will take place between 1.37 and 1.67. Next, we are going to define functions for the chromatic aberrations of the camera objective. For this, we are going to create horizontal and vertical coma functions. Next, we are going to add a function to add noise to our simulated images. Next, we combine these functions. Next, we are going to create a function to get the labels for each image that we created. In this function, we are going to plot some of the images that we want to resolve and visualize for our dataset for training. Once we have created our dataset visualization and we are happy with the images that we see here for training, we proceed with creating a neural network. In this case, our neural network has 3 convolutional layers followed by 2 dense layers. Next, we are going to train our neural network. If you would like to train your model that you created, you can set a train model parameter to true. This will start the training process, but this will take a bit of time. For the sake of this tutorial, I will set it to false. If you set it to false, it will load automatically the trained model. Once we have a trained model, we can evaluate the results from the network. Here we are predicting some of the results and showing the returning error as a function of radius of the particle, as a function of refractive index, and as a function of sigma. And finally, we have a look at the predictions of the network on experimentally obtained data. We load the experimental data set and then predict the data with the network and show the results that are predicted by the network. You can see here that the network is predicting accurately the radius and the refractive index of different kinds of particles of the experimental data. This was all for this tutorial. Thank you for watching. You can find the links to the code that we used in this video or the links to other tutorials that are included in the Deeptrack 2.0 package. Thanks for listening.